So here we are given a piece of information and the diagram, and it says in the diagram DE is a tangent to the circle at E, and DFG is a secant intersecting the circle at F, and G. DE is equal to EF equal to FG. H is a point on EG such that FH is parallel to DE, right? And also here you have your diagram DE, which is parallel to FH, and also you are told that EF is equal to FG and DE, right? Okay, so let's just go down and see this diagram as a whole. So here is our diagram. We just said that EF is equal to ED and also equal to FG, right? And also you are told that DE is what is parallel to FH. So that's one of the important information: parallel lines and equal lines. And also you are being told that DE is a tangent to the circle at E. So we have some of the important things in this diagram, and they are so important such that you will have to give reason every time you find an angle here, because they've given you that information. Okay, so let's just go back to the note so that we can highlight those important information. So here let's look at this, since we are given it that here we have a tangent. So there is a theory behind the tangent, and also we are told that there is parallel lines. So there is theory also behind parallel lines, and also these are also important because if you have equal lines, it means you might have a triangle. Then that triangle might be a isosceles triangle, right? Okay, so let's move on to the questions and see if we can be able to answer questions concerning this information which they just gave us. So let's go to the questions. So the first question says, determine, giving reasons, 3 angles each equal to DEF, and you will be given 4 marks. So how do we give reasons after finding these angles that are equal to DEF, right? Where is DEF? DEF. So this is what? This is E1, which is the DEF, right? So let me write a table here so that I can be able to write my statement and reason, because they just told me that determine, giving reasons. Okay, so here I'll write my line. So here I have a line, then so here is my line. So this is what I'm gonna do. On this side I'm gonna write statement, then on this side I'm gonna write a reason, then also here. So here is statements, then here is reason. Okay, so they want an angle that will be equal to DEF. So I can just say DEF, so it's E1, I can just say E1 because I know it will be easy if I write E1. So it's an angle that will be equal to E1. So let's come here and see which angle is equal to E1, right? Okay, first of all, I know something here. I know that DE is what? It's a parallel line. So how do I consider parallel lines and look at angles concerning parallel lines? I know something about parallel lines. I know that parallel lines, if you have a line that is parallel to the other line, they will form maybe something like Z or N. So between those angles, if this line is said to be parallel to this line, then this angle will be equal to this angle, right? So what are they called in parallel lines? They are called alternating angles. So here, if I see DE being parallel to FH, so DE, and then I see EF, then I see FH. I see something like this. So if E1 is here, you can see E1, it's up here, then angle F2, it's up here. So I can just say, okay, angle E1 is equal to angle F2. So I'll come here and say angle E1 is equal to angle F2. Then what is the reason? Alternating angles, because I see what? I see them because of what? Because of parallel lines. So you only see alternating angles when they are parallel lines, right? So DE is parallel to FH. So DE is parallel to FH, right? So this is the first angle that is equal to DEF, right? So what is the second angle? So the second angle will be, I know that DE is a tangent. So what is the theorem behind the tangent? A theorem behind the tangent says an angle between a tangent and a chord is equal to the alternating angle from that chord. So what will be the alternating angle from this chord, right? The alternating angle from this chord is what? Is G. So I will say here angle E1 is equal to angle G. Why? I know that because it's a tan chord theorem. Right? And also you can see now we have two. You need one for you to be able to move on to the next question. Okay? So now I know something also. I know that FG is said to be equal to FE now, right? So if I have two lines that are equal, then I will know something, that this angle, it will be equal to that angle in this triangle EFG. Because of what? Because these two lines are what? Are equal. So angle E1 is equal to G, angle G is equal to E2, so E2 will be equal to E1, right? So I'll just say, okay, angle E1 is equal to angle E2. Why is that? I know that, okay, let me first write here angle E1 will be equal to angle, then here you will say equal to angle G, because this angle is equal to this angle while this angle is equal to that angle, right? So the reason would be that I know that if I have angles that are equal, that are opposite also, I know it's because they have equal sides. Then you'll be done with this question. Then you can move on to the next one, because you've found what? You've determined the three angles that are equal to DEF. right? Let's move on to the next question. So the second question says, prove that triangle DEF is similar to triangle DGE, and it consists of how many marks? 3 marks. So how do we prove that this triangle is what? It's similar to this triangle. Okay, so first of all, let's just highlight these triangles. So DEF, how do we highlight this? Let's just highlight it so that we can be able to see it. So this is the small circle, so I will just highlight DGE now because I'm done with DEF. So let me highlight their big triangle. So here you have two triangles, so you can see that D is the shared angle between these two triangles. So this angle between these two triangles is what? It's common, because triangle DEF is having that angle, and triangle DGE, triangle DGE, it's having that same angle. So you can come here and say angle D is the common angle, is a common angle, right? So you just found that this angle, it's what? It's common. And we just found out that here we have E1, and this E1 was said before that it's equal to this angle, right? We've proven that above, that this angle is equal to this angle, where we found that it's also equal to F2 and also equal to E2. So just come here and say angle E2, angle E1 is equal to angle G. Okay, so you just say it was proven above. Let me give a space. Okay, above. Then now you are left with this angle for what? For this small triangle. But for this huge triangle is this whole triangle, E1 and E2. So you can just say angle F1 is equal to angle E as a whole, even if you don't say E1 plus E2. If you say angle E, it will be enough. So just say here you have your third angle of a triangle. Then you'll be done by proving these two triangles that are having the similar angles. Then now you can just say, therefore triangle DEF, it's what? It's similar to triangle DGE. Then why are you saying that? Because you just proven that this angle and the other angle and the third angle are equal for these two triangles. So let's move on to the next one. So the second angle from the proof above. So here we have B question. It says prove angle D to be equal to 72 degrees, and it consists of 5 marks. So where is angle D? Angle D is this angle. So how do we prove that angle D is equal to 72? This angle. How to prove that this angle is equal to 72? Okay, So let's just let one of these triangle angle to be equal to x. Okay, let's just let this one f1 to be equal to x, so that we can be able to find angle D. Let angle f1 be equal to x, right? Okay, so this angle is equal to x now, right? So but we know something about triangles. We know that every triangle, its angles are equal to 180 degrees when you add them together. So this angle, if we add this angle and this angle and this angle, they will add up to 180 degrees. So let's just do that. So here we said that this one is equal to x, right? So this angle is equal to x. So since this angle is equal to x now, this line and this line are equal. So therefore this one will be equal to x also, right? Okay, so now we have two angles, right? So we can say E1 is what? It's 180 minus what? Minus these two angles. So let's just say angle E1 plus angle D plus angle F1. All these are equal to 180 degrees. What is the reason for this? We can just say, okay, sum angles of a triangle. Don't have to write a lot of things, just give them simple reasons like this. Sum angles of a triangle, just abbreviate and write these type of things, because this is represent triangle. Don't have to write triangle by words because it will waste time also. So here we have what? We have E1, right? So we can make the substitute formula D, okay, or else we can just say E1 is what? E1 will be equal to 180 minus these two angles. Okay, let's just say E1, which is angle E1, is equal to 180 degrees minus 2x, right? Because these two, we just found out that these two are what? Are x. But remember something now, ne? Here you know that angle E1 is equal to 180 minus 2x, and you know that this angle E1 is also equal to this angle and also this angle, right? So we can just say, okay, angle G is equal to angle E1 and also equal to angle E2, right? These two, it's what we need now. This one and this one is what we need now, right? So we can just say, okay, angle E2 is equal to, plus angle G, this angle and this angle, angle G are both equal, right? Are both, when you add them together, they're gonna give you this one. They're gonna give you what? They're gonna give you F1. Why is that? We know that if you are having a triangle like this angle and this angle, when you add them together, they will give you this angle. This theory, it says opposite interior angle of a triangle, when you add them together, they will give you what? They will give you the exterior opposite angle, right? Okay, so we know that this angle now and this angle are equal to that angle. So let's just write that down, because we know that E1 is equal to E2. We're just gonna say here we have 180 minus 2x. then we close our bracket, then we say plus, then we say here 180 minus 2x, then we close our bracket also, then we say is equal to angle F1. We know angle F1, right? We know angle F1 is said to be what? Is said to be x, because here it's x. So let's solve for x. So here we know that, okay, we have 180, it will be 180 plus 180, then you'll get what? 360 degrees, right? Then here you have minus 2x, then also here you have minus 2x, you'll get minus 4x, right? Then on this side you have what? You have x. So you can just take this and put it to the other side. Okay, so you're just gonna be left with 360 on this side. Then on that side you will have minus 4x plus, because it will be negative on this side, but on this side will be positive. So here we have 5x, right? So if you divide both sides so that you can find your x, divide both sides by 5. So here you will have x is equal to, let's press the calculator and see, 360 degrees divided by 5. What do we get? We get 72. So here it's what? It's 72. So you come here, you say, okay, x is equal to 72. So here is 72. Therefore, d also it's what? It's 72, because d is also equal to 72. Then you can write your reason why you said d it's equal to x, because first of all you made this f1 equal to x. Then by reason you said d1 is equal to x. Why x there? You knew that this line and this line are what? Are equal, so this angle and this angle are going to be equal. So now angle D, you can just say, okay, angle D it's equal to 72. Then also you know that this one is equal to 72, right? Okay, so let's move on to the next question. So here on our third question it says, if it is further given that df is equal to k, df here is equal to k units, and fg is equal to 2 units. Where is fg? Fg is equal to 2 units, so this one is equal to 2 units. Prove that k squared plus 2k is equal to 4, and it consists of how many marks? 3 marks. So here you know that it's 2. This side also it's equal to this side, so you can come here and write 2. Then also this side is equal to 2. So how do we prove that k squared plus 2k is equal to 4, right? So we know that we've proven that this triangle and this huge triangle is what? It's similar. So how do we prove now? We're just gonna say DE, this DE over DG, right, of this triangle, because in similarity we said this side it was also similar to this side, because they started by saying DEF. So, and they also called this one DGE, right? So we're just gonna say DE. Let's write here DE over DG. DG is equal to DF. Where is DF? We're just gonna say DF over DE, also DE, right? So DF over DE, right? Okay, so now you can see, okay, now if we ever we substitute these values, this is what we're gonna get. We're gonna get this. So let's just substitute the values. We did this because of what? Because these two triangles were similar. We're just gonna say because this triangle DEF was similar to triangle DGE, to triangle DGE, right? Then we're done. So now let's just substitute values here. DE is what? It's 2, okay, and also DF, where is DF? DF is what? It's K, okay. So, and also what is DG? This DG, where is DG? DG. So you can see here you have DG distance is K and also 2, so you can add these together, say 2 plus K, K plus 2, you're gonna get what? 2 plus K, so that's the distance. And also DE, where is DE? DE, this is DE, and it consists of 2 also. Then you can cross multiply now, then you can get your values. So here you'll be 2 times 2, then you get 4 equal to 2 plus K times K, it will be 2 times K, it will be, let's just write it like this, okay. So here will be K times 2, it will be 2K, then K times K, it will be K squared, then here you are left with 4. So you can write it in this form if you want. So you can just say 2K plus K squared is equal to 4, or just say K squared plus 2K is equal to 4, which is what they want, and you will get your what? You will get your 3 marks, right? So let's move on to the next question. So here they say determine, giving reason, the ratio of GH, where is GH? GH is here, over GE, which is GE, in terms of K. Then you're gonna get your 2 marks. So we know that, okay, they want this GH over G, what? This GE. What does this remind us? This reminds us of proportionality theorem that says if this side is over this, it must be proportional to this one, right? So now we know that, okay, this, since this line is parallel to this one, proportionality theorem applies. So here we were given that is 2, then here we were given that is K. So the ratio of this side is equal to the ratio of this side. So therefore we can just say GH over GE is equal to GF, which is this one, GF over GD. Then you know that GF it's what? It's 2. Then GD it's what? This GD is 2 plus K. So here you'll get 2 plus K. Then that's it. You are done with this. Then you can write your reason why you said this, because of proportionality theorem. Proportionality theorem. Right? Then we are done with this question. So please do make practice of these questions. I will make sure that I post more questions concerning these type of questions. So make sure that you practice them. Good luck.